Hello, everybody. This is the final study guide for gravimetric analysis. This is done by Nancy Romero and myself, Alexander Soriano. So what is gravimetric analysis? So this is a formal definition of gravimetric analysis. So it's basically straight out of the book. But to really know what this means, it's basically knowing one chemical amount, mixing it with an unknown chemical amount. It could be of unknown concentration, doesn't know the ratios, all that stuff. And then it forms a precipitate. And then you take that precipitate and measure it out and using the known to the other known to find out the unknown. It's all pretty straightforward, pretty simple. You use masses most of the time. The mass is going to give you all the information that you want and also the balanced chemical equation. That's going to give you the information that you need for gravimetric analysis. So some keywords to know that you're going to do a gravimetric analysis problem is if a precipitation is made, and also if it's titrated, or if a precipitate is filtered out. That's usually your key to know that it's gravimetric analysis. So these are your basic important formulas that you need for gravimetric analysis. It's all pretty basic, all your plain stuff that you learned along the way. So let's jump right into a question. So here it says that arsenic in a 1.22 gram sample of pesticides was converted into an arsenate ion by suitable chemical treatment. It was titrated using the silver ion to form this pesticide as precipitate. And then it tells you, so right there, there's one of your keywords, precipitate. So if it took 25 milliliters of a 0.102 concentration percent of silver ion to reach the equivalence point of this titration, what is the mass percentage of arsenic in this pesticide? So right there, we had both precipitate and titrated, so that keys you in that this is a gravimetric analysis. So the first thing you're going to want to do is you're going to want to balance out your chemical equation. This will most likely be given to you. If not, it'll tell you what reacts with what. That way you could make your own balanced chemical equation. So you're going to want to balance it out. This is going to give you a ratio of what to what. That way you know what to plug in when you're changing for moles. So if it took 25 milliliters of this concentration of the silver ion to reach equivalence points, you're going to have to find the moles of silver. So there you go. You plug it in, your 25 milliliters to liters, and then compare your concentration to 1 liter. And that's going to give you how many moles of the silver ion you have in this mixture. Then you're going to take this silver, the concentration of silver ion, or your moles of silver ion, I should say, and plug it into your different ratios. So, you know, you have a 3-to-1 with arsenic to the arsenate ion. And then you have that silver, or sorry, there's silver to arsenate ion, and then your arsenic to arsenate ion. And then using the molar mass of arsenic at the end to your 1 mole of arsenic that you have there, basically like a straight comparison, you come out with 0.0637 grams of arsenic at the end of it. And then from that, we could get our percentage by comparing our total mass of pesticide to the grams that we discovered of arsenic in it. And that gives us 5.22% of the pesticide was arsenic. So it's all relatively straightforward. It's really using your balanced chemical equation and your conversions from grams to moles and moles to grams to really settle out these questions. So here's a practice question if you would like to solve it. So here we see that it gives you 2 keywords right there, titrating and a precipitation reaction is taking place. So that's telling you that it's going to be a gravimetric analysis problem. And they're also kind enough to give you the balanced chemical equation. So as you can see from balanced chemical equation, it's all 1-to-1 ratios. So we're not really too worried about all that. So there's 2 questions that you're going to have to solve. 20.2 milliliters of this silver ion concentration. Right there, it's going to tell you how many grams of chloride ion are in that sample of water using that sample right there, 20.2 milliliters. And then another question, if the sample has 10 grams, how much of that 10 grams, what's the percentage of the chloride ion in it? All relatively straightforward. Just use your balanced chemical equation and then separate everything, and then use your comparison at the end to find out what's the percentage and how much of the sample is chloride. So go ahead and pause the video now if you want to give it a shot. All right, here are the answers, and thank you and have a good one.